So now I have written the word resistors. 3 resistors are taken. Usually you can show like this also. If you observe carefully, they are connected one after the other. I am using the word one after the other in battery. This is the cell. It is a positive, it is a negative. Second, another cell, this is a negative, it is a positive. Next, another cell, it is a negative, it is a positive. Negative of the first is connected to positive of the second. Negative of the second is connected to the positive of the third. That is what we have. Usually we used to draw. But you are not supposed to draw like this. It is allowed. 3 resistors R1, R2 and R3. You can see 2 different ends. Wire is taken, connected to ammeter, then ammeter to switch. If you put a dot, closed. Further it is negative, positive, negative, positive, negative, positive, sufficient 3 cells. And then further connection, you can see. Positive and negative. Current flows from positive to negative. One thing remember, if you keep here ammeter in each case, each resistor, it shows same deflection. Same deflection means it shows that current is flowing same. In series connection, current is flowing same, constant. You know, decorative lights. We use the word fairy lights during Ganesh festival or any other functions at home. We decorate from outside. You can see the small bulbs. They are connected in series. Means current flow is the same. If you test with voltmeter, watch, voltmeter. If you test with voltmeter, here it changes. Here voltage is different. Here voltage is different. Here voltage is different. That is why, remember one thing, always we connect voltmeter in parallel. Always. I told you, it has a high resistance, it has a low resistance. Trick is, it is a negative, write a negative. It is a positive, opposite is negative. Positive, it is negative. Here, ammeter to voltmeter, opposite connection. Battery to ammeter, same connection. You remember that trick. Either you can draw voltmeter here or upper side. It is allowed. I am showing this. Total, it carries 1 or 2 marks. This is information about what you call resistors in series. But how to remember? I write trick. I tell you. Trick is choose your path for different. Which is different in resistors in series? Different is voltage. That is why you start the journey from voltage. V equal to V1 plus V2 plus V3. Because voltage differs. Sum of individual voltages, potential difference. It is total PD. Apply Ohm's law. V is equal to IR. V1 is IR1. See here, no change in the current. IR2, no change in the current. IR3. Further, it is simple. I write here IR equal to I common. I write R1 plus R2 plus R3. I cancels. We write RS equals to R1 plus R2 plus R3. Means sum of individual registers is nothing but equivalent. We write equivalent. Total, we use the word equivalent. This is the information I mean to tell you. Expression RS equal to R1, R2, R3. Remember one thing, very interesting part. In the series, if you add, say for example, 1 ohm, 2 ohms and 3 ohms. 3 plus 2, 5. 5 plus 1 is 6 ohm. Means in a series, resistance is always more. Always more. That's why it allows less current. This one you have to remember. Always less current. I will tell you in case of resistors when connected in parallel with the same resistances, it differs. So this is the explanation. You can create your own sentences. 3 resistors are connected in series and ends of the wires are connected to ammeter, switch, battery and then voltmeter as shown in the figure. First you have to draw figure, then connections, then explanation. When current is passed, it flows same, but the difference is differences in voltage, voltmeter. You can do this experiment, then you will understand. They did this. That's why they told V1, V2, V3, not I1, I2, I3. This is about what you call in resistors in series. Now we move on to resistors connected in parallel. Watch. Parallel connection, same. How we are going to connect? What we do is like this. Common connection is there. Common. Here we draw resistor, and ends are connected like this. Over. Don't worry about the color things. Simply you watch. A, it is B, it is R1, R2 and R3. When the current comes, it differs. If you test with the ammeter, here with R1, R2, R3, different current. So we say I1, I2, I3. Voltage remains same. For example, at home, voltage is fixed. 220, not more than this. But variation in case of resistors when connected in parallel. So different is what here? Current. So we start our journey from difference. I mean to tell you which is different, which is differing. I1, I2, I3. Current is differing. You write I equal to I1, I2 and I3. I, according to Ohm's law, it is V by R. I1, V by R1. I2, V by R2. I3, V by R3. Easy it is further. You can understand taking common on the right hand side. Taking common. Just watch. V by R. V by R is equal to V common. You will get 1 by R1, 1 by R2, 1 by R3. V cancels. We now take this as what you call 1 divided by RP. Resistor connected in parallel. Equivalent resistor is equal to say 1 by R1, 1 by R2 and 1 by R3. There is also some, but it is a reciprocal. When you use the word reciprocal, you will come for parallel connection. Remember, at home, we are having parallel connections. not series. If you test now with 1 by 1 ohm, 1 by 2 ohm, and 1 by 3 ohms. 3 to the 6, 1 the 6. I hope LCM is 6. 1 6 2 3 3 2 6 1 3 1 2 1. I hope 6 plus 3, 9 plus 2 is 11. It is 1 by RP. We have to take reciprocal according to maths. LHS and RHS, it should be applied. It is 6 by 11. 6 by 11 means 6 divided by 11. 11 5 55. 0.5 something you will get. In the previous series, we got 6 ohms in series. Here we got 0.5, which is less in parallel. So resistance is less, current is more. That is why they made parallel at homes. Because TV, laptop, air conditioner things, refrigerator, and you can say one more thing, washing machine, all they almost require more current, large, say up to 15A. There is a difference. Electricians, they know about it. And for electric fan, electric bulb, mobile charger, it is up to 5 ampere. They divide. So they divide the current. So for you can see at home, TV connection, projector connections, all the wires are thicker. You can watch it. More is the area, less is the resistance. Less is the resistance, more is the current. So that is why it is the derivation proof for what you call parallel. Explanation you have to write. Connection should be like this. It is a parallel connection. Assume that this is TV. Assume that this is electric bulb. It is a fan. When current comes, different devices use different values of current. They don't use same current. You cannot apply 15 ampere current to the bulb. See the tungsten filament. Make it off. High temperature. It will retain the heat and produces, it will not melt quickly, produces light. So that's why devices are made like that. Some devices are they convert directly electrical energy into heat energy. You know, iron box, electrical iron box. You know, geyser, water heater. You know, tea making kettle, electrical kettle. Nowadays, in almost all the homes, we are bringing electrical, cookers, electrical cooker, direct into heat. Filament like that they use. They don't convert electrical into heat and light. Heat and light in case of bulb, tube lights. So different devices are made. Different devices. Some devices like, electrical energy is converted into two things. One is mechanical energy, rotation of the blades of fan, even mixer grinder, even in projector, fan. See, they made idea. That's why we have to remember Joule, H equal to I square RT, Joule's law. Product of square of current, resistance of the wire, and time taken to flow. Plays very important role. We use a fuse. Low melting point. If large current comes, remember fuse wire cuts off. It saves the appliances. Always fuse is connected in series for this purpose. First, electricity has to sign over fuse. It will check what is the voltage. How much is the voltage? 220 volts. Okay, allowed. How much is the current? 15 ampere. Allowed. More than that abrupt flow of current, it will cut off by itself. That's why it is made of alloys. So in this way, remember in this total chapter, I have explained usually and I have covered almost all the points where you can understand easily. Already we have explained. In the notes, everything is given. The next part is solving problems. We will solve. Okay. sacrificed.